Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about a Leetcode question number 563. Binary tilt. Given the root of a binary tree, return the sum of every tree node's tilt. The tilt of the tree node is the absolute difference between sum of all left subtree node value and all right subtree node values. If a node does not have any left child, then the sum of the left subtree node value is treated as 0. This same rule applicable for right child also. So let us take this example to understand what they are asking in this question. See here, let us take this example first. Okay. Now, I can say, first of all, for each node, we want to find a tilt value, right? What is the tilt value? I can say a tilt value of that node is the sum of right subtree or left subtree minus sum of right subtree, and we want to take the absolute difference between them, right? Okay. Now, for this one, I should take a modulo 2 minus 3, which is equal to what? 1. So the absolute difference would be what? 1. Because what is sum of the left subtree? It is 2. What is sum of the right subtree? It is 3. That's it. Okay. Now, what is the tilt value for this 2? I can say the tilt value for this 2 is 0 because left subtree also there is nothing. Right subtree is also nothing. So we will assume this is 0. This is 0. 0 minus 0 is also 0, right? So it will be 0. For this 3, it is also 0. So I can say 1 plus 0 is equal to 1. So 1 is our set. Can you understand this? Now, let us consider this second example. Now you can clearly understand how we are going to solve it, right? Okay. First of all, what is the tilt value for this 4? I can say it's sum of all left subtree and the sum of all right subtree. Okay. What is the sum of all left subtree? It will be 10. And what is the sum of all right subtree? It will be 16. So the value will be 6. So the tilt value will be what? 6. Okay. Fine. Now, let us go beyond it. Okay, now, let us consider this 2, okay? For this 2, I can say, this is my left subtree, and this is my right subtree. Yes? No. I want to take the difference between them. So, it will be 3 minus 2, and it will be 2. 2 is the tilt value for this 2. Now, for this 3, it will be 0. For this 5, it will be 0. For this 7 also, it will be 0. Because they don't have any child, right? They don't have any child. Okay? Now, for this 9, I can say 0 minus 7, which is equal to 7. 7 is the absolute difference, right? Okay. So this 9's tilt value will be what? 7. Now we are going to add these 3 values. So 6 plus 2 plus 7 is equal to what? The answer is 15. So we want to give the output as what? 15. Can you understand this example? Now, by seeing this example itself, we can say, go with a brute force solution. What is a brute force solution? Okay. First of all, take one node. Take this node 4 and calculate sum of all left subtree and sum of all right subtree by traversing them, and take the difference and add it with the result. That's it. Simple, right? So that is the brute force approach. And go for this 2. Then do this operation for the left subtree and also right subtree. Then go for this 3. Again do it. Go for this 5. Again do it. Go for this 9. Again do it. Go for this 7. Again do it. So this can reach a time complexity of O of n square, because you want to place a node and we want to check what is the sum of left subtree and also sum of right subtree, such that the time complexity will be what? N square. Okay. Now space complexity is what? O of x. Because we can do this in what? DFS traversal, right? We can do this in DFS traversal. In DMS traversal, we use a recursion. So in recursion, it uses what? Internal stat. That's why what is the space complexity? Just O of x, the height of this tree. Right. Now we want to optimize it, right? Okay. Let us consider this first example itself. See here. To compute this 2, what else we need? This 3 and this 5. Okay. To compute this 9, what else we need? This empty, that means the null, and this 7. Okay. To compute this 4, what we needed? 2, 3, 5, and 9, this empty, then 7. So I can say, instead of going like that, take this answer of this 2 and return here. Take this answer of this 9 and return here. What I mean is, let me draw this again. 4, 2, 9, then 3, 5, 7. 3, 5, 8, 7. Okay. Now, just look at this carefully. First of all, I'm going to go up to the depth. Then I want to return it such that we can reuse the sum again. Okay, hold on, I will tell you. First, I will take a result as 0 initially. You want to return the sum of the tilt value of each and every node, right? So that, okay, now, initially I am here. Let me take a Pirai traversal. Let me take a Pirai traversal. Okay, now, I will go to this 2, right? Okay. Hold on. If you go to this 2, again I want to go to this 3. Again I want to go to here. Then only while coming back, I should do some operation, right? So, instead of this post pre-order, we want to take a post-order traversal. I said wrongly, okay? This is a post-order traversal. Now, when it reaches null, it returns what? It returns 0. Because null values will be written as what? 0. Now, again, it goes here. Here also it is null. So, it should be written as 0. Now, what is the tilt value of this node 3? It is 0 minus 0 is equal to 0. So, this result will be updated as 0 plus 0 is equal to 0. Hope you understand this. Okay. Now, again, it goes here. Then it also comes here. Okay. Now, this 5. Here also nothing. Here also nothing. So, these two will return what? 0, 0. Now, what is the tilt value of this 5? So, tilt value of 5 is 0 minus 0 is equal to again 0. So, 0 plus 0 will be 0. In result, we want to count it. Okay. Now, again, it will backtrack. Now, for this 5, what should I return? For this 3, what should it return? So, I can say from this 3, it returns like a sum of the left subtree and the right subtree, and take myself, because I am also included in your left subtree, right? For this 2, this whole thing is a left subtree, right? So, it will take like my left subtree is 0. My right subtree is also 0. Take myself also, it is 3. So, what is the value here? It is 3. So, the value returned from the left subtree is what? 3. Now, the value returned by the right subtree is what? 5. Now, the tilt for this second node, node 2 is 3 minus 5. The absolute difference will be 2. Add it. Simple. Okay. Now, again. Now, this 2 should be written, right? While I'm returning this 2, okay, hold on. What I got from the right subtree, it is 2. What I got in the left subtree, it is 2. What I got in the right subtree, it is 5. So, at this board, this should be the left subtree and the right subtree sum, right? So, 3 plus 5 and add myself, it is 2. So, it's equal to 10. So, we got 10 as here. Okay, now it's time to what? I have to go with the right. I am going right. Okay, again it goes left. What is it? It is null. So, it returns what? 0. It does what? 0. Right? Whenever I found a null, I should return what? 0. Okay. Now, it goes here. Now, it is 7. It is also null, right? These both are null. So, it also return what? 0, 0. So, I will do what? Yes, I will do what? I will make 0 minus 0, which is absolute difference of 0 is again 0. So, 2 plus 0 is equal to again 2. Again 2, right? Okay, now. Again, it returns what? My left subtree is 0. My right subtree is 0. Take myself, is equal to 7. So, 0 plus 0 plus 7, 7. So, it returns 7, it returns 0. Now, when I am taking the absolute difference between these 2, I can say it is 7, right? That's the tilt value of this 9, right? So, plus 7, which is equal to 9. Got it? Now, again, this 9 gives like my left subtree is 0. My right subtree is 7. Take myself. I am also your right subtree. Okay, so 9, which is equal to 16. So, see here, at here, it is what? 10 minus 16, which is equal to 6 as a difference. So, add 6, which is equal to 15. Right? Again, this node will return what? This node will return, my left subtree is 10, my right subtree is 16. So, it is 26, plus take myself as your subtree. So, it is 4, and returns to the function call. So, function call will be what? 30. That is what? Sum of all node in this tree. So, see here, 4 plus 2 plus, these will lead to what? 10. Now, these will lead to what? 16. 16 plus this 4 is 20. 20 plus 10, it is 30. I got a 30, right? At last, in the calling value, I will be getting what? The sum of the tree. But that's not our answer. Our answer what? In this result. This result value is our answer. This 15 is our answer. Hope we understand this. Okay. Now, by doing this method, we can optimize our time function as O of n, because I'm just passing entire only one time, right? Entire tree only one time. This is the approach where we are going at last. Then while coming back, we are just solving that problem. It is like what? Breaking a main problem into sub problem. And by solving those sub problem, I will reduce and I will get the solution for a main problem. Okay, now what is space function? It is a height of this tree. So this is a time and space function analysis. Now let us see the code. See here, a result is equal to 0. We say declare the result as 0. Now this result is what? An enclosed variable. That's why I used what? Non-local of the result inside what? DFS function. Now, if not root, then what should I do? I said just return 0. Okay, and if not root dot right and root dot left, which means what? If it is leaf, then what should I return? I should return the roots value. That's what I done here also, right? Here also at this 3, what I return? Just 3, right? Just 3. We can do like, we can go here, and we can also return like that also. No problem, okay? Now, left is equal to dfs of root dot left and right is equal to dfs of root dot right. I'm going to the function call for left side and right side. And at last, for the root dot value, I will add left plus right. I'm adding what? Left plus right. And result plus is equal to absolute of left minus right. So I am taking that node tilt value and storing in result. And what I should return? I am returning the roots dot val. Can you understand this? Now at last, I'm just calling that function. Now I'm just returning what? The result. Just result. Okay. Let me submit it. Yes, it is submitted successfully. Now see here, we don't want to write this value, right? Instead of this, we can write here directly, like plus just the left subtree and right subtree sum, right? Just put right. We can also do like this, okay? And it is not necessary. This is not necessary. We can also comment it. Let me run it first. Yes. Now let us submit it. Yes, it is submitted successfully, right? See here, we don't want to give this also, because if I give this, it directly returns the leaf value. If I don't give this, it goes for left and right. It will be 0 plus 0 and the roots value. Okay. And here also we can directly do what? Directly return what? Root dot val plus left plus right. We don't want to convert the root dot val as the sum of left and right subtree like that. We don't want to do that. Clear, right? Thank you.
The other hand of dad.